What we're going to do here is demonstrate the acid-catalyzed hydrolysis of the triacylglycerol below, or here. Now it tells us that this is acid-catalyzed, so that means we're going to have some acid involved here. This is how we write acid, just a hydrogen ion. And then hydrolysis, that means we're going to be using water. We're going to be using water to break this molecule apart. Now a little bit about the structure of this molecule. These three carbons here and the oxygens here, this is the part, we might think of this as the backbone. This is the glycerol part here. And here you might recognize that you have a carbonyl group and then CH2 12. What this is this is just trying to show us that there's a long carbon chain here, but we're too lazy to write it out. It takes up too much space. We just kind of shorthand it by saying CH2 12. So there's 12 carbons plus one more, there's 13 carbons there. That's all. Okay, so we're going to take water, we're going to split this apart. And where we're going to split it is going to be right here, like this. And we're going to add a hydrogen to one side over here onto the glycerol side. And then the OH comes over here on this side here. So I'm going to redraw this and show what it looks like when the water molecules have been used to split this apart. So here what we have is these hydrogens have been added onto the oxygens here to create this structure. And this structure here is our glycerol. And then we're going to end up then with three of these here, these long carbon chains with hydroxides attached to them. So we're going to take these OHs and we're going to attach them on here. So it's going to look like this. We're going to have HO, carbon, double bond O, and then we're going to have the rest of this molecule here, which is going to be CH212, CH3. And we'll do that 3 times. Now that we've written this out 3 times, you might recognize these groups. We have an alcohol here on the glycerol side, and then on this side here, we have the carbonyl group and the hydroxyl group here, which gives us a carboxylic acid. So this is just going to be a long carbon chain with a carboxylic acid on the end. And we have a fancy name for these things here. So this is glycerol. This right here is glycerol. And then these 3 long carbon chains here, these are fatty acids. And we call them fatty acids because, like fats, they have long carbon chains, and then acids because they have the carboxylic acid group on there. And curiously, if we were to take this reaction and go in the opposite direction, then what we'd be doing is we'd be taking water and removing water to pull these 2 molecules together. And so that would then become, if we're going in this direction, removing waters, so we just go like this, and then go like this, removing waters, then that would be a dehydration synthesis, so removing water to join these things together. So it can go in both directions. Going this way, we're going to be adding water. Going this way, we'd be removing water. For this problem, what we're going to be doing is the saponification hydrolysis with sodium hydroxide. Now, that's a lot of big words, but what we're going to do is we're going to take our triacylglycerol here and we're going to react it with sodium hydroxide. So for this one, I'm going to write out the sodium hydroxide. Sodium hydroxide, and there'll also be water in this one. Although the water doesn't actually get used in the reaction itself. Now, you might recognize the same basic structure from the last problem. And what we're going to do, just like the last problem, is we're going to split something apart here. In this case, it's going to be the sodium hydroxide. And we're going to add the hydroxyl groups this time over here. And then we're going to split these molecules right here, add the hydroxide groups to this side. And then on this side over here, this side, the fatty acid side, we'll add the sodiums. So I'm going to redraw this here. So there's our basic backbone of our triglyceride, or our glycerol. And we're going to have hydroxyl groups on here. And those came from our sodium hydroxide. And then we're going to have sodiums attaching onto our fatty acids. So I'm going to redraw these fatty acids here. There's one fatty acid. There's 3 fatty acids. Now, each of these oxygen atoms here are going to be electronegative, and they are going to be attracted to then these sodiums, which are electropositive. And you might recognize this or remember this as a fatty acid salt. So we have glycerol here and 3 fatty acid salts. We have a fancy name for these fatty acid salts, soap. And so basically what you're doing is you're taking the triacylglycerol, which is fat. This would be like animal fat, or could be plant fats as well. You're going to be adding a strong base to it, sodium hydroxide, and you're going to be creating glycerol and soap. And this is how soap is made.